Hey guys, hope everyone's doing well out there. I'm going to start off here with a little teaser. I have made some headway on the cluster, specifically those little white connectors that you see there that are all boogered up from someone trying to do a repair before I got a hold of these. Um, those little white connectors have been one of the hardest things that I've ever had to try to source in my career. And I'm going on 6 years as an engineer that sources things a lot. Those are very obscure. The company that made those has swapped hands several times, and they were really hard to find. But the good news is I found them, and I needed those to be able to continue progress on a cluster bypass or a new version of a cluster to make it easy to plug and play for all of you out there that have a Ford Think. There's not a whole lot of use to completely having to cut all your connectors off to use something new. So anyway, without that out of the way, kind of back in a little bit more of a normal cadence, I'm going to show you some things I've been working on lately. We're going to go through some of the service switch and fuse wiring that you might see boogered up on a cart. We're going to go through some of the old charger misconceptions, some of the new charger differences, and how to select an algorithm, and then talk a little bit about battery orientation, and I'll wrap it up. So nothing too crazy in this video. The next one I'm going to put out, I'm going to show you how to buy a different key. If some of you have intermittent key issues, we'll go through how to solve those. DC-DC converter, and we'll talk about lights and converting to LED lights. So stay tuned. I'll make sure the next one comes up a little more quickly, but let's go ahead and jump into it with some wiring issues. So next up, we're going to work on the service switch and the fuses. This is how this cart was. You can see everything's cut, and here's two fuse holders that are just kind of like taped together. On these older carts, you'll see this is a common halfway fix, I guess you can say. The fuse holders that are installed in here over time, they just get really, really hard to pull out. A lot of people strip them, and you see a lot of issues like this one here. So what I end up doing is cutting these out. I'll show you that in just a second, and replacing it with a connector, because the earlier carts that have the service disconnect on the center post actually don't have a way to remove that whole assembly without cutting the wire. So since this one's already been all hacked up, that's exactly what I'm going to do. I'm going to cut this wire. If you have batteries in your cart, please make sure that you disconnect them, because you will throw some sparks, because what I just cut is actually before the fuses. So just be really careful with that. I'll show you here in the next video, or the next little segment, why I do this, why I'll go ahead and fix all this, fix everyone's previous work, even if the cart is working. Just want to make sure things are done right, and that this doesn't cause an issue for new owners down the road.
So this is a reason why you want to check other people's work. I just took this tape off, and look how easy that comes off. It's not the same size spade. You can see it's a lot smaller. And that is what causes intermittent connection issues, which are a pain to diagnose later. Same with this side. So this is a good fuse holder. I am going to use it. But we're going to solder these connections to make sure they don't come off again.
On the original carts, the service switch is on the center mast, and a lot of people end up breaking these fuse holders. So I cut this one off. First off, there is no way to service these. On the newer ones, there's a connector here, but on the older ones, there's not. So I cut these off. I took it home. I put a 3-pin connector in on this one, even though there's 4 wires coming out. So these 2 wires, which are purple on both, they actually go to the same fuse down here at the bottom, which is for the gauge and motor controller. The middle one is the charger,
And it actually does not go through the on-off switch. You can still charge even with the switch off. And then the top one is for the DC-DC converter. So we're gonna solder this back in line so that if we ever need to repair this, we can. And then I'm doing this a little different than the one I did before, but I'm gonna put screws in here so that if anyone ever needs to take this off in the future, it'll be a little bit easier than putting rivets back. So we're gonna do that real quick, and let me get this soldered up and we'll get that back restored where it needs to go. So how this works, this is actually the output. You have power coming through the top part of this contactor. It goes through the fuses, through the switch. Sorry, I have this backwards. So power comes through the switch to the top and bottom fuses and then out to the cart. The middle one is actually just connected straight through. The on-off switch does not affect the charger. So anyway, let's get this wired up and we'll get this put back together. So we have gray to black, black to gray. All right, next up we have our 2 purple wires through blue and back to the 2 purple wires. So purple and purple. When I say purple, they're orange and purple, but purple is the denoting color. And these are really tiny little wires. Look to be about 18 or 20 gauge. And lastly, we have this yellow wire. And it'll go to this red wire. Good on that. So now we have a connector that will let us service this part if need be. And I wouldn't have done this unless the part needed to be serviced, but this was all broken and you have to solder the connections on the back. So that's the reason that I did that. So what I like to do typically is route these around the back here. And then you can mount it, as it were, right there. And then this connects to this top piece. However, I'm pretty ornery about how this happens. You typically want your highest voltage connectors as close as possible to the stud. So you want to put this on first, and then you can attach your fuse wire. Just the higher amperage draw items shouldn't have to go through more pieces of metal to get where they need to go. And we'll tighten that down, put this cover on, and we'll be good on this one. Your contactor, that's what this wire is down here. It also has a connector, and it comes from the factory with a connector, thankfully. and just kind of push it right there.
So these fuse holders at this point are about 20 something years old. They've carried a lot of current over the years. They're really brittle. If you haven't had one break yet, you might, especially if you have to change a fuse. Also, for those of you that might have some intermittent issues, some fuses blowing, there could be some issue with your fuse holder. Sometimes that's rare. I would say, you know, you want to check kind of the other parts of that circuit before a fuse holder, but on these carts with the age and the types of fuse holders they used, I wouldn't call it out of the question, especially for these. Depending on if you have an early or a late model version of your Ford Think, you might either have two of these slotted style fuse holders, or you might just have one. These suck, to be quite honest. When you put a slotted screwdriver in the front right here, typically depending on how hard it is, how much thermal cyclings happen, this will actually just shear off, and then you're left with a fuse holder that you can't get the fuse out of. So what you end up having to do is desolder or cut these connections, and then you can solder on a new fuse holder. If you do have to replace these, I personally would recommend getting a thumb screw style one. So those are going to look something like, if I can get out of here, something like these. This is the original model that's on there. I would not go with these. I personally bought these because I'm trying to keep these carts stock and as original as possible. But they're $15 for one on eBay because they're not made anymore. I will say they are very over-engineered. They're very overbuilt. They can carry up to 30 amps. However, there are a ton of options out there. So if you just search for a panel mount fuse holder, I mean, there's all kinds of stuff. Blue Sea Systems is actually a really great company. This is a thumb style turn version. So $4. You know, there's a lot of options out there. So I would certainly recommend getting something that has a thumb style turn as opposed to a slotted screwdriver turn. I would say the only thing, just make sure that whatever you get is rated for at least 10 amps, but realistically it really should be 15 or 20 amps, just so that thermal cycling doesn't cause it to fail even sooner than maybe some of the failures you've already experienced. But that hopefully will get you going if you do have a fuse issue.
There's probably not too many of you that still have one of these guys. They're extremely heavy. I didn't want to scratch up my wooden workbench, so it's sitting here in a chair with an old jacket under it. These chargers themselves are not that bad. I mean, obviously the quick chargers are better. The issue really is this Amphenol connector. You can see these first two pins, we have power and ground, and they are black. And the issue here is that the charger puts out about 10 amps as it's charging. And the problem with that is this connector is rated for about 10 amps per pin. And so what happens over time, the heat cycling, where this connector and the other end mate together, really start to experience thermal cycling, and that's what makes these fail. And so then you have a charger that's not, or a cart, Ford Think, that's not charging, and most people just discount the whole connector. I've disconnected this one. But the other issue is the wiring that they use is also very thin. But inside of here, you can disconnect everything. And what we're actually going to do is swap out this connector with one that has some beefier pins. And we're going to do that on the cart side as well. So that's what I'm going to show y'all. If you have a Ford Think that isn't charging well, this is probably your culprit. We'll get into this a little bit. You got to make sure your cart service switch is off and
take the fuse out for the charger, because even with the switch off, it's still live, and we don't want to blow up anything else. There's some few other things going on here. Not going to name these out exactly because I can't remember off the top of my head, but I have 12 volts or sorry, 72 volts in ground. We have a charger inhibit line, we have a charger select line, and then we have a temp positive and negative that go to a little thermistor type of resistor near the battery pack. That is kind of like a safety precaution. And that's really it. So we're going to mostly focus on that. But the other thing you can look at doing, there are two ceramic fuses in here. If you have a charger where your connector looks good, although I seriously would recommend replacing this, because what happens on the other end, the plastic will actually start to degrade, and since they put 72 volts positive and negative right next to each other, it can short circuit and cause a fire. So that's what we're going to prevent today. And first thing I'm going to do is check these fuses, just do a little continuity test, and we'll go from there. I don't have this screwed in yet, but here is our new connector versus what's left of our old one. It is slightly bigger, slightly bigger. And so you do have to, you know, Dremel out the hole a little bit to make it fit. I have all my connections in here. And so what I did, here are the new pins. This is a 12-pin connector. You don't need this many at all, but this is what was available. This is actually one of the old pins that came out of this guy. And so what's interesting, it's really hard to tell, but these are smaller in diameter than these. And so what I did, even though this new connector should be capable of carrying 10 amps on each conductor, I actually doubled them up. So this is the 72 volt positive connection, and it's going to two connectors over here, and 72 volt negative, same thing. So that's, you know, way better safety margin. We're going from 10 amps to theoretically something that should be able to carry 20. So got all that wired. We'll drill my little holes to actually mount that, and then hook it back up to this guy and get it all plugged in and make sure everything works the way that it should. All right, let's go over this pinout really quick for the charger so you'll see what I did. I'm going to move this kind of over here to the side. The thing to keep in mind, this is the connector from the back side, if you're looking at the female connector. So pin 1 is actually over on the right hand side, and it goes right to left instead of left to right. And what that means, if I just show you this here, you can kind of see it right there. So you can see the red wire if you're looking from inside the charger, the back of this connector is on the right. So that's 72 volt positive. And then next to it, the black wire is 72 volts negative. So that's what I mean by that. So now if we look at this, that's how that works. So number 1 right here, 72 volt positive. Then we have 72 volt negative. And then 3 is charger inhibit. This is a very weird one. This one needs to be tied to 72 volt negative in order for the cart to operate. The other thing, if you tie this to anything higher than floating, so either the options are it's not tied, you have an open, so let's just say this goes over, this goes here, and this is an actual physical connection, and you have a switch. If the switch is open, then the cart will not move. However, if you tie these together where the switch is closed and you complete that circuit, then the cart as long as that is tied low to 72 volt negative, the cart will operate. If you tie that charger inhibit line to anything else, even 12 volt positive, you can really do some damage to your cluster. So just be careful with this if you're using a different charger, or just trying to bypass this circuit. It needs to go to 72 volt negative, or return as they have it listed here. Other things, so then just continuing on, battery temp, sensor, power, and return. On your Delta Q charger, if this has been swapped out, these two wires are actually tied together and go to the white wire on the Delta Q. So white. And then where they go to the actual sensor near the battery, these wires, the gray and blue and gray and green, the sensor is actually chopped off at the battery side, and the white wire from the Delta Q charger is soldered to both. So I'll try to show you what that means a little bit later. And then 6 is battery type select, and 7, 8, and 9 aren't used. They actually don't even go anywhere on the connector to the actual cart. But battery type select is also not used if you have a Delta Q charger, if it's been converted to one, because you do the battery type or the algorithm select actually on the charger, and I will show you that a little bit later in the video. And here's what I was talking about with the gray and blue and gray and green wires that were cut, and the white wire, which here it's wrapped in orange tape, but the white Delta Q temperature sensor that was put in its place. Most of you, if you have a Delta Q charger, are going to be pretty familiar with it, but I'm going to run through this real quick. On your Delta Q charger, there's a lot of advantages over the classic silver charger. One is actually having a display to kind of understand what's going on. This really works well as a debug tool, especially if you have a no start condition with your cart, meaning it won't go. This has an amp meter. It'll show you kind of the scale of amps that it's putting out to the charger. All the way up at 6 means that it's full output. Down at 1, it's kind of more of a trickle charge. It has a bulk charge indicator, which we're going to keep that in mind. Bulk charge indicator is the one that looks like the battery's 80% full. Charge completion indicator, AC indicator, y'all can read all that. The flashes, these are really helpful. If you plug in your charger, this can actually help you start troubleshooting. Typically, you'll see a battery high voltage, or more commonly, a battery low voltage scenario, which will keep your cart from running. This is very common if you forget to turn off the service switch. You go away for a few weeks, you come back, turn your cart on, and don't get a contactor click. It could be that your battery voltage has gotten too low. And if you plug your charger in and look at the flashes when it first starts up, you'll see that. Selecting a charge profile, this is what I'm about to show you how to do. So we're going to do that in real time. You need to do this if, first off, you need to check it. Regardless of if you think it's right, it's an easy thing to, what I'm about to show you, pull out the fuse and check your profile. But then we'll also go through how to change the profile. And what I was mentioning on the bulk charge indicator, that's where I'm going to be looking in the video. It's the indicator that looks like the battery is 80% full. For charge profiles 7 and above, they'll display on this by a series of blinks. So charge profile 7 would be 7 blinks right here, and then they give the example of 13, where you'll see a 1 with a pause and then 3 more blinks on this indicator. Anything from charge number profile 1 to charge 6 will also show on the amp meter, but honestly, it's easier just to look at this bulk charge indicator light and go off of that. So anyway, I'll show you how to do this real quick in real time by using your fuse, and we'll get you a charge profile confirmation if nothing else, and if you need to change your profile, I'll show you what some of those look like real quick. So there are several different algorithms that are on Delta Q chargers for the Ford Think. These are just a few of them. Typically, your cart is going to be on charge profile 6. That is for the Deca 8G31 gel cells that were originally put in these carts. However, you know, people over time change to AGM batteries or flooded batteries. And if you do that, then you need to change your charge profile. You will notice there are a few weird ones on here. For example, 5 is listed on here twice, and there's an AGM profile and a flooded profile. My cart actually didn't have 5 at all on it. We started with algorithm 6. It went through 7, and then I actually put it on charge algorithm 8 because I'm using 104 amp hour. They're actually Trojan batteries, but it's specified that they're for AGM groups 24, 27, 31, which is what I have in there. AGM, and then it would be good for 80 to 150 amp hours. So anyway, this is the one I had. It's also temperature compensated, so it uses the thermistor, the little white wire that goes onto the negative post of the battery pack to make sure everything stays nice and warm, but not too warm, so to speak. So anyway, feel free to look through this. You can cycle through all of these, or cycle through all the algorithms on your cart. You're not going to have all of these. It would be good to cycle through, write down what you have, and then find the closest one to your type of battery. So let me show you how to cycle through an algorithm, and then how to actually save that algorithm and make sure it's confirmed as well. There's several different charging profiles that are built into the Delta Q charger. Also note, this is the 7212 variant of this charger. This was the one that was designed specifically for the Ford Thinks. If you buy a 7200, do not just plug it in to this connector. It will blow up your cluster. So we'll talk about that a little later. The interlock on the Ford Think is very strange. It's commanded by the cluster, or it commands the cluster to allow the car to drive. And if you put too much power through it, it'll blow up some transistors on the cluster. So just keep that in mind. But this will work for any Delta Q. If you do have a 7200 Delta Q installed that is working, got it installed by a shop or bypassed the vehicle disable circuit, all good. This is how you'll change the algorithm on any Delta Q. So first thing you'll do is you'll want to remove the charger fuse, which actually should be this middle one. So you just pull it out, and then you'll plug in your charger. And you should see it flash. So this is algorithm 6. So 6 is flashing, but then if you look here, you'll also see 6 flashes. And it only does it for 11 seconds. So you have to be a little quick with this, but let me show you that again. So let me let it turn off. It has some residual power in it. It takes a second after you unplug it to turn off. All right, we just heard it click. So we'll plug it back in. Check this one. And then you'll quickly insert your fuse for 3 seconds. 1, 2, 3. Pull it back out, and you should be on the next algorithm. Let's do that again. 1, 2, 3. Now if you look down here, you'll see 7 flashes. We want to do it one more time to get to algorithm 8. 1, 2, 3. One, two, three, 4, 5, 6, 7, 8. And once that's there, you want to push this in and keep it in. The charger will come on, and then to set what you did, you want to unplug it. Wait till you hear the charger go off. I just heard the relay click. And then to confirm, you'll pull your fuse back out. Plug your charger back in, and it should show 8 flashes. And it does. So that means that we're on algorithm 8, which is an AGM algorithm specifically for group 31 batteries. And that is what we want. So we put your fuse back in, the charger should start up. And these batteries are mostly charged all the way. So typically you'd see that light go all the way up to the 6th bar, but you can see it is actually sending a slower, what am I trying to say? Lower amperage to the battery. So this will eventually fall. You can see that it's over 80% charged because of that light. And then when it's completely done, the battery full light will come on. And this was a surprise, a dumb charger that the customer had wired up, immediately fried their cluster, then pushed the cart in their backfield for about 10 years until I came along and bought it. So word to the wise, don't use things and don't try to hook them up if you don't know what you're doing. Reach out, I'll be happy to help you any way that I can. All right, so we got this cart hooked up. Everything is plugged in, so we're about to give it a try. Had someone, or saw someone ask the other day about battery hookup. So this is battery 1, and it goes counterclockwise. So 1, 2, 3, 4, 5, 6. On battery 1, you should have, if you have the Delta Q charger, you'll have this white cable that has a temperature sense thermistor on it. You also have a battery 1 negative cable that should be wrapped in orange tape, and then the battery 1 negative actual post that comes, I believe, from the motor controller. It's a big, 2-aught wire, whatever. And this is the negative side, so these go negative, negative from left to right, and then the 2 in the front are inverse, so you can see the negative and negative. So and then the ones on the end are opposites too. So if you just follow the negatives, negative on left, negative on left, negative at back, and then negative at right, negative at right, negative at front. There's also a large fuse that bridges between batteries 3 and 4. It's located right under the passenger seatbelt post. And here's a diagram I found online that better shows the wiring diagram. All right, guys, I'm going to leave it here for now. This one was a little more boring. I know it's just a lot of nuanced stuff, but I think it's stuff people should know. It helps keep these carts on the road, and that's really what all this is about. So hopefully you found something here useful. Like I said, next time we'll do some stuff on the keys, the DC-DC converter, as well as lights and LED conversion ideas. And then past that, we'll talk a lot about the cluster, and there might be multiple parts to that just because there is so much there that needs to be covered. But we'll get to that a little later. Let me continue working through that and see where I get. And I will keep you guys posted. So expect another video next week on keys, DC-DC, and lights. And we'll go from there.